Railway Conversations with Dr. Frank.
Hello and welcome to another episode of Railway Conversations with Doc Frank. I'm your host of this podcast, Doc Frank, and my guest in today's episode is Danny O'Connell, originally from the UK but now living and working in Brisbane, Australia on the Cross River Rail project. Danny is a long-term specialist in the area of testing and commissioning of complex railway projects, and accordingly, this is the core of our conversation. It's a very captivating conversation, at least it was in my opinion. Way too short for my taste, and I'm pretty certain that I will get Danny again in another episode in the future. I hope you enjoyed today's episode, and if you do, please tell your friends about it. Hi, it's Doc Frank here. Real quick, I want to let you know about one of the best CBTC trainings in the world, if not the very best, but you always need to be careful with superlatives. It's the CBTC Kickstarter online course. It consists of 30 video lessons, that's the 3 with the 0. In total, over 11 hours of training content, talking about everything from the basics of CBTC, current standards, the benefits of CBTC, the key functionality of it, the supply industry, application tips and tricks, lessons learned, do's and don'ts, case studies, arguably the most comprehensive training that you can find anywhere on the topic of CBTC. There are a few additional things that make learning easier for you that you may not find on any other online courses. One of them being an immersion plan that helps guiding you through the training course and progress it in a finite period of time instead of just having it sit there for months and months on end. There is access to an online study group where you can connect with other students who are doing that training course at the time and form learning groups. There will be live coaching calls once every 2 weeks. And after the training, you will not be on your own. There is an alumni community that allows you to ask questions about the course content on an ongoing basis. So it's basically education for life. You can inform yourself about this training course and register to it on my training portal, which is docfranktraining.podia.com/CBTC Kickstarter -online 2023. I repeat that, docfranktraining.podia.com/CBTC Kickstarter -online 2023. I look forward to seeing you at that training, and until then, please enjoy my upcoming episode of this podcast. Danny, welcome to the podcast.
Welcome, Dr. Frank. I'm really pleased to be here.
The pleasure is all mine. You've been a recommendation of a previous guest of mine, Victoria, who I believe is your partner, if I'm not mistaken. And it seems that you've...
Yeah, that's correct. Yes. So Victoria is my partner, and obviously we worked on different projects with each other as well. And she spoke very highly of the podcast, and thankful that she recommended me to come here today as well.
Great. Well, that's excellent. And one thing that we didn't discuss previously, but which would actually be very interesting for me to talk about, is how you basically shape and develop your career as a couple. I hope I'm not catching you off guard here. And I apologize, we didn't discuss it previously. But I think it's hard enough for one person to keep finding interesting projects one after one, and trying to do this with two of you, basically trying to find jobs in the same projects, which are both interesting, which are both fostering your respective careers, which are both quite impressive. I think that's really that's quite a feat, and probably not that easy to find and not so easy to come across. Yep.
That's a really good point, Dr. Frank. Yeah, so for us, obviously, we're both professionals who've worked in the railway industries for a majority of our working careers. So it's been quite, we're independent in relation to the work environment that we live in as well. So again, it's quite a small industry, the railway. Again, multiple projects that have similar stakeholders. But we find it from a professional perspective quite easy to have that cut off as well. So we're not direct peers, but we work in the same, let's say, atmosphere of sense, as well. So, yeah, it's enjoyable for us. Again, we both live and love the railways and working on these mega projects. So it's quite a, for me, it's a real benefit as well, having someone that I can come home to and we can speak about what's happened today, what's best for project, only for a small amount of time. Obviously, then we get back into our normal personal lives and situations. But yeah, I think it's a real benefit for us. And as I said, both professionals at what we do and working independently of each other and having some relationships relevant to program delivery, program reporting. Obviously with TNC, it's a fundamental part as well. So.
Yeah, I can very much relate to this because my wife is from the industry as well originally, even though she's not practicing anymore. But she's got an understanding of what the railways do, what I'm doing, and there are obviously within the normal boundaries of confidentiality and stuff, we are capable to talk about those things that are on my mind that's happening with the railways. And I find it, as you said, I find it really good as well to have a partner at home that you can, within reasonably limits, discuss work issues as well. Obviously not the entire time. I would be the first one getting trouble with that if I was talking about work all the time. So it needs to be somewhat balanced, of course. Let's talk a little bit about your career, which has been quite impressive. So I found out that we had a joint time working at Thales, even though in different places back in 2009 when you were working on the Dubai Metro project, and I was trying to win a CBTC job in Sydney for Thales, where we used Dubai as one of our key references. You can pretty much start wherever you like, but maybe if you give a quick summary of the career that you've done to date and what brought you into your current role, that would be really good.
Yeah, of course. Again, I'm going back some time now, Dr. Frank, as well. So when I first started working, actually, so I left school at 16. So I started in an apprenticeship, basically. I didn't go to university. I went straight into a 5-year apprenticeship, actually working in electrical and telecommunications, predominantly working on London Underground. So when I first started, we was looking at the telephone maintenance system. This was basically maintaining the telephones for, let's say, station staff, for back of house, for the main offices of LUL. In addition to that, then we started doing cable putting. So the cable putting element was the base level of a system, basically. So putting a cable in point to point, learning how to terminate the cables, and then after several months, learning to test the cables, and then what do the cables connect to? The system. So my career at the start was very much a progression of the base level installation part, then moving into how do we test, what does that mean for a transmission network, onto data networks, onto telephone switches. So I started at the bottom, if I put it that way, and built layer by layer by layer up. And my career sort of developed that whole process. So every job I've been on, I've learned. I've actually really learned. It's been a real benefit for me. And I don't believe you ever stop learning as well. So that was the initial concept. So when I first started in 1995, I worked for the same organisation for approximately 9 years. So again, working all over the UK, predominantly on the railways, but working in Europe. We worked across Holland, Sweden, Switzerland. Again, predominantly looking at fibre optics. That was the next progression. So in the dot-com boom, fibre optics literally transferred the way we transmitted information. So data, megabits, it just went up and up. So I've always had a tendency to want to work in a telecommunications data, electrical environment, but predominantly systems based. So I said, started with LUL, moved across Europe, working onto railway systems, also airports as well as another similar environment for me. And approximately when I was around about 28, 29, the potential, or there was an opportunity post working on the TNET project. So the TNET project in the UK was a complete upgrade of the telecommunication systems. So that was basically new radio systems in the tunnels, new CCTV cameras, a new data transmission network across the whole of the network. So it was a mega project of its sort, particularly working on a historic line like London Underground with the restrictions that we have. So that's where I sort of learnt my trade from moving into fibre optics and data comms into radio systems. So looking again, as I said, leaky feeder, Tetra, GSMR as well. And then ultimately, again, around about 28, 29, I had the opportunity to move to Dubai to work on, obviously, an iconic project, the Dubai Metro, as you rightly mentioned, where we could have potentially crossed paths as well. So obviously stepping into Dubai, I was working for Thales. Thales were basically a multi-part contract relevant to the delivery of the signalling system, delivery of the station, the comm systems, and delivery of the OCS, which is the operational control SCADA. So that was the head end of all the projects that I've ever worked on. Dubai is the most integrated. I've never ever seen anything like that project in relation to the head end equipment, how it was integrated into one, let's say HMI or interface for the actual operator. It was unbelievable, very, very difficult to deliver. Like every project, it has its issues. The main element of it was predominantly because of the location, installing equipment on, let's say, wayside infrastructure that's not used to having the sea, the sand, the salt implications to it as well. So it was quite it was a learning job for me. I really enjoyed Dubai, particularly looking across obviously the signalling system, the traction power, the communication systems, and how that integrated into one head end and that operational control centre, or the BCC. So that was the next step up in my career, going from, as I say, single systems, again, cabling, data networking, into systems interface and integration, and then into head end control. So that was my first experience of working in the control rooms, but then ultimately looking at the delivery of the train systems as well. So understanding how that train system interacts from, let's say, the train to the wayside. What is the transmission path? How do we transfer, obviously, the signalling information? How do we transfer the communication systems, be that the critical radio, be that GSMR, Tetra as well? So it was really where I found that I grew up on that project. So from the base level of what I knew to the point of entry into Dubai Metro to the point of conclusion when I eventually left there. So I completed both the red and the green line delivery, so quite an iconic date of 999 for the red line opening, and then subsequently the green line opening as well. The last part that I was actually working on the airport, so the Concourse 3, which was the new terminal or element of the terminal for Dubai Airport. That it facilitated the A380s, so this is approximately going into the new A380s being delivered and the double-decker trains, planes. So again, an enjoyable experience for me. Any questions on that, Dr. Frank, relevant to the build-up? Or
a couple of comments that came to my mind. One, I found it very interesting that you started on telecommunications networks, and I was just thinking that if you work on something that is just there to connect different systems and basically make different components into a system, it's probably not too much of a step to actually go into getting interested in the systems, getting interested in the whole thing, like how it all plays together. Dubai is obviously quite an iconic project, and this commissioning date of 999, it was probably even more cast in stone than, I don't know, the opening of Olympic Games or something similar event. Yeah. So I think not getting this done in time would have been quite a catastrophe, at least reputational. So well done on doing that. And the other question I had regarding Dubai is, from memory, that was in a system based on induction loops. So I think the communication between CBTC Wayside and CBTC Onboard was done via induction loops in Dubai.
Correct.
And which seemed to be a bit like a relic from the past, but at the same time, you're avoiding a lot of problems that you may have with the Wi-Fi radio. Yeah, simply because the distances between the induction loop and the antenna underneath the train are so minimal, and the risk of interference with some other users are basically non-existing. Yeah, because there's really nothing that can come in between there.
Correct.
Yeah.
Correct. Just to answer that point there, again, going back to Dubai, there was multiple radio systems, as we mentioned. So you're right regarding the induction loop of the signaling system. So again, an old relic, a tried and trusted system that delivered signaling. The actual real issues and concerns in Dubai was predominantly around the communication systems or the radio comms. So be that the Tetra system that was based off a security network of, let's say, Dubai, and now that interface specifically around the transitions as trains moved at speed from the subsurface, from the surface into the subsurface, and that loss of communications, again, critical comms. In parallel to that, we had systems called the VBS, which was the video broadcasting system. So this was live streaming of CCTV images from the train, also a fully duplex solution that allowed adverts to be broadcast to the train as well. And at the time, this was brand new solutions that were being deployed there, and the testing that needed to be done was we tested and we tested and we tested again. And what I mean by that was that there was lots of, again, due to the environment as well, I did a first major project that had been installed into the Middle East from a metro style system, and understanding the impacts of what the heat, the sun, the salt, the weather can do to this equipment, that needs to be obviously protected against it. And it was a really, really intriguing project from that perspective. And going back to the first question, again, my interest has always been the railways. I used to play with a Thomas the Tank engine set when I was a child, and it's just developed from there. And I've all throughout my career, I've enjoyed it. I enjoy the projects. I enjoy the delivery part of it. But the question of the base level, I've started, as I said, from the cable part, the lowest level of transmission to how it's connected. What are the systems that connect it? And that's why, again, going back to fibre, like the backbone of systems for us is usually the fibre network solution. And the way that I explain that to people at that low level, when I speak to, say, a child about it, it's about the veins. It's the veins in the body. Yeah, that's the way that I explain it. And the top level, your brain, is actually the control center with the different systems working there. Yeah. So that was just my little element of where I got to in Dubai. In parallel to that, when we started testing the signaling system, the radio systems, that was my first real exposure of how to do dynamic testing, and understanding that we have various elements of how we start putting a train into a new piece of infrastructure, demonstrating the kinematic envelope, at slow speeds. What do we then have to do regarding testing the onboard systems with the wayside? What does that look like? Are the systems ready, running at slow speed? And you try to explain this to people. People just assume that the systems work straight away, that the train will fit, not understanding that we have these small building blocks that gets us to opening a railway for passenger service. So that was my first real exposure. And I suppose that what I learned there has been with me for the rest of my career. So in conclusion of leaving Dubai, I came back to the UK, worked on the SUP upgrade program, which is 4LM now, basically looking at the deployment of the new rolling stock from Bombardier, again, without the signal system at the time. So this is more to do with, again, putting trains into sections, confirming correct side door enable, validating driver-only operation as well to allow these trains to start operating on the network. A really good year. Again, I learned more elements for me of how we demonstrate PTI, the platform train interface. So that, again, filled into these building blocks of dynamic testing. And what I mean by that, in my mind, there's eight key principles to dynamic testing. If I look at it from a railway solutions perspective, there's what we would call that low speed joint proving test. So the first time you put a train into a new piece of infrastructure, you validate that the train fits, so the kinematic envelope. You'll validate that the pantograph would fit to the rigid overhead conductor bar or the OHLE, that the wheel actually fits to the rail as well, Then you start moving into what we would then call your radio coverage checks, be that your radio comms, so your voice comms from your driver to the control centre. It could be that you're validating the track database. So if we say from a CBTC perspective, you're validating the onboard map, to the actual track releases and installation of axle counters as well. And you validate these systems again at slow speed. You then start stepping up into what we call your functional testing. And to me, that's predominantly the settling slow speed test. So start a mission. What happens when we implement a temporary, let's say a TSR? Yeah. If we want to prove route proving, so point to point to point. And then at that point, you'll get to a maturity level when you can start testing settling protection. Yeah, that's a big step for us. Yeah, so these first tranche of testings are slow speed activities where you're not actually utilising the settling as a protection function or safe separation. You're demonstrating it with alternative methods. But then you get to a point where you want to run the train at line speed, but you haven't tested the infrastructure. So there's always that trade-off between whoever's doing the build and obviously the settling entity to say, right, now we can run the train at line speed, but we're validating the infrastructure at speed as well. So it's always quite an interesting point from that element. And then we start moving on to what we would call our platform train interfaces, yeah. So stopping accuracy, yeah, your measurements between obviously the train and the platform. What would happen if you have a platform CCTV for your train dispersed basically from the platforms as well? And then we get into particular rolling stocks test. And what I mean by that, do we need to do journey time and performance? Do we need to load the trains up with weight? And what we mean, different, obviously, configurations of the train. That could be from AW0 to AW3. And in layman's terms, what does that mean? Train is empty, train is full, or basically fully laden as well, as the terminology we use. And you can test different scenarios of that, of your ATO stopping. Again, what happens when a train is fully laden, arrives on a platform. And then the final part of that test campaign of them principles is when we go into multi-train testing. So demonstrating close headway, demonstrating safe separation, squadron testing. What happens if the train in front stops? What is the impact? What are the recovery rates? And the final part of that is like what I call dynamic integration testing. So when we demonstrate all of the systems working in unison as they should, but what happens in degraded mode scenarios? Let's get reliability. Yeah, let's make sure that we're testing as much of the infrastructure and as much of the time that we can, basically, as well. So that's where I sort of lined up in my head of how you would build a dynamic testing program for a greenfield site, particularly for a brownfield site, be that metro systems, be that high speed, be that tramways. They're all pretty much the same in the baseline principles. Some slight variants, but that's how you would successfully deliver that side of it. So going back, so again, before I step through, Dr. Frank, any questions relevant to what I've just presented there?
There is so much stuff going through my mind as you keep talking. It's unbelievable. I mean, one thing I can't help myself mentioning is I was wondering how many careers for railways in the UK may have started by Thomas the Tank Engine. I just needed to say that. The other thing, and that's probably the last thing about Dubai, is I could imagine Dubai is a fully unattended system. GOA4, Rate of Automation 4, for those of you who don't know the acronym GOA. And Dubai didn't really have a fallback system in the classical sense. So many railways that operate on GOA4 have some kind of a conventional fallback system with some simplified signals and stuff like that. But to my knowledge, Dubai didn't have any of that. So I could imagine that is a majority of the testing, or a significant part of the testing was really the testing of degraded scenarios. So what's going to happen? What's going to happen if something doesn't go right? And that leads to the next remark regarding telecommunications. It's not just there is one sender of a piece of information, and then there's a receiver, and then everything's fine. If you think about more complex interfaces, and one example may be the interface between the train, the CBTC, and platform screen doors. There is so much information that needs to go back and forth until the point where actually both doors open pretty much at the same time and allow passengers to get in and out. And again, you've got degraded modes. So, for example, what happens if one of the platform screen doors doesn't work, but the train door is still operational? How do you prevent the train door from opening so that people basically get out of the train and smash against the closed platform screen doors? All these kind of things. It can be really, really complex and really complicated. And the last observation before I let you go on, because it's you should do the talking and it's super interesting for me, is I was very conscious when you mentioned seemingly trivial things to test, like that the wheels of the train actually fit the rail. And I could imagine that this very fundamental testing, which obviously is pretty catastrophic if it doesn't work, that could be something that many people just take for granted. The trains have been built to spec and the rails have been built to spec, so obviously it needs to fit. And this obviously, I believe, is a big danger that you really need to avoid in testing. And I think you explained it very, very well, to really start at things that other people may take for granted and say, yeah, but we need to test it anyway, because if it doesn't work, it's a real problem. And there's still a big problem between wheels fitting on a rail that the train runs somehow and wheels fitting on a rail that the train runs really well and really smoothly. And I think it's the latter that you really want to achieve. And that's really where the trick is. And that's what makes it so obvious why these kinds of tests are really, really important. Because you want trains to run smoothly at slow speeds, you want to run trains smoothly at higher speeds, medium speeds, and so on. So probably all these scenarios need to be tested when you really want to do your job properly and when you really want to end up with a railway that ticks all the boxes.
Exactly. You've nailed it there, Dr. Frank. For us, it's ride quality. There's two parts that fall out of this, yeah. Ride quality is one part of it, but then also the noise and vibration impacts as well. Again, looking at tunnel environments, let's say even where we've got external neighbours that are quite close, these are big impacts. I've seen it on tramways where let's say a floating slab track has been installed, but people have not appreciated the noise and vibration and the proximity to, let's say, people that live adjacent to the railways. Yeah, these are big impacts to people's lives. This noise, so it's again, going back to the point, and that's the reason we test. Yeah, people have let's say, people that are not from a systems background or let's say a TNC background sometimes don't appreciate the volume and depths that we go to. And I just want to go back to the previous point. Platform screen doors, we do or die by these, yeah. So that door inhibition test you mentioned, yeah. So the scenario in my head is that, again, a train pulls into a platform, let's say Canary Wharf as an example from the Jubilee line, yeah? We've got lots of passengers waiting for that train. If there was no signage, yeah, on that train, yeah, as it pulls in, the doors don't open, you have passenger overflow issues at that point, yeah? So that baseline test for me is that a train door has failed, yeah? The communication path between, like you said, from the onboard to the settling to the PSD, yeah? Train pulls in, there's a visualization, there's a big X on top of the door explaining to people not to board at that location, yeah? And likewise on the train, a relevant alarm is generated to the back of house as well to identify we have an issue here, yeah? And again, people don't understand that these are probably the most integrated tests that we get, that we have a failure on board or a failure on the wayside. And what does that mean? So it's information being presented directly. And that's a really, really good part. And then the second or the first part of that point, door synchronization. Yeah. From a pure PTI security process, yeah, door synchronization needs to work. We need to make sure people are not entrapped behind that PSD door as well, yeah? And it's making people understand. There's people, again, with PSDs, people have an opinion that, okay, we can do 1,000 cycles in the factory. Yeah, we can do 1 million cycles. Trains to actually deliver the PSDs to the platforms, do these cycles. The part that's the fundamental element of that is the integration. Yeah, working in unison, and that big part there. And that always comes back to me of going back to some of the TNC philosophies of like, how do we de-risk, let's say, a PSD interface, yeah? We can test it, as I said, in a factory. We can test it in a lab, yeah? However, the real interface is when you put the three systems next to each other. So that could be the train, yeah, PSD and signaling. Best locations for that predominantly are in test tracks, yeah? You can de-risk that activity and these issues and fine-tune it before it comes to the tunnel. And that's where I believe sometimes people don't appreciate how you can maximise off-site testing and what de-risking of an activity actually means as well.
Yeah, And again, that triggers a couple of other points. I just made up my mind. We need to have a second shot at this. That this is the time will not be enough to discuss all the stuff that's on my mind. A couple of things here, a couple of observations here. Number one is when we opened our first metro here in Australia, which is Sydney Metro, there were a number of teething problems after commissioning, even though interfaces like, for example, a platform screen door interface was really tested to death. But was it? So I could imagine, and without knowing it for certain, that was basically just an educated guess. I could imagine that a lot of those teething problems came from trains that didn't undergo 100% tests. So what I mean by this is you have your system test, your component test, and then your integration test. So there's like a test setup of a train and the platform screen door and the CBTC in between and so on. So that's all nice and good. And then you have a number of test trains, normally 2 or 3, which really undergo a very, very comprehensive test. But I think there is a point in time, especially if you're under time pressure, if you are pressured to open up the railway and start operations, where you say, well, you know what? There's a fleet of 22 trains and they're all the same. They all have been built according to the same design. So they have the same brakes, the same braking system, the same controller for the train doors, the same this, the same that, the same and the other. So if we have 3 trains going through 100% test and they all perform beautifully, do we really need to have the same rigor of testing for the other 19 trains? Or can we just cut a few corners there simply to speed up the process? Because we don't really have the time to accommodate 100% test on each and every train. So what would be your approach to that? How can you minimize the risk of things not working at day one of operations, while avoiding a full-blown 100% test of each and every unit, especially for like train fleets where you've got large numbers of repetitive tests that need to be done?
I think you're right. It's the variable. So in my mind, there's 2 ways of doing this from a project perspective. Yeah. So if you look at it from a purely PSD part, as I mentioned earlier, that off-site testing. Let's say you've got a trains in a depot, be there any country in the world for a new project. If you install, let's say, an element of a signaling system, an element of a physical platform screen door there, you could pass every train through that as it comes out. So they're type testing every time. The main part for me of actually testing in the tunnels, again, it's the soak testing. So you would have as per your technical requirements, and say across your VCRM, so basically your link of a requirement to an opportunity or action, be that a test. You can perform these tests. I really believe it's the soak testing part that is the benefit. So what I mean by that, if you have 16 hours a day for testing, as an example, in a tunnel environment, the 8 hours, what you would utilise that for is run a train up and down. So not under a test, but just a soak test. It will pull up into every platform. It will open a door. Yeah, and you test and you test and you test again. That's my way of trying to maximise the time of both off-site, of putting these trains all through this same environment, and then ultimately whatever trains you need to get into that tunnel. But again, volumes of trains are always going to be, I don't believe you can do 100% of the testing on 100% of the rolling stock. Yeah, you can validate elements of it. You can do some type testing. You can do some regression testing, unless you have all the time in the world. But predominantly, it comes down to program pressure, as you rightly mentioned. So I believe it's the variables and how we can de-risk it. Again, my mind, depot or yard being one, and then let's say maximising the hours that you've got during a testing period. And to be quite honest with you as well, Dr. Frank, we're always going to be reduced for time. In a test environment, I'm looking predominantly at the railway corridor here, we're always going to be reduced for time that we have, because potentially when we start running trains, the build isn't finished. So the way that we try to mitigate this in my mind would be Monday to Friday, we have 16 hours of, let's say, train testing, real train testing. We may get 10 or 11 hours of actual wheels rolling, so test time. However, the second 8 hours in my mind could be that function. Running a train up and down. Friday evening, we put the trains to bed. we hand back to the construction and the maintenance works to be done. Likewise, on a Monday, they hand back to us. And in parallel to that, the way that I would literally to deliver a project, every 6 weeks, we have a week shutdown of testing. What does that give us? That gives us time to deploy any new software. Yeah, if we found errors or logs, but it also gives the construction and maintenance team time to go back and resolve any works, but also give the test teams a little bit of respite as well. So that's the way that I would look at that whole delivery cycle from end to end. But again, with unlimited, let's say, restrictions on time and people wanting access as well, because the big part that I always find in say, delivering metro systems with new tunnels and new stations is you've got two very different work streams that are intertwined, but both want priority across each other. So that's the railway corridor, then the station system delivery. And the impact of that station system delivery on the railway corridor upstream could be someone's isolating a distribution board that has downstream impacts that we don't have voiced from, impacts the signaling system. So it's always quite difficult to play them off, but they're both fundamental delivery milestones for a project that need to be controlled and work in parallel. If they don't work in parallel, then you're going to find it very, very hard to succeed. And I don't know if Sydney was the same as well in that respect. It was
I think it's a general challenge for testing and commissioning activities. And you kind of touched on this, that you never have as much time to do your work as was originally planned, because you always come at the end, at the last bit of the program schedule before things are handed over to the operator or operation start or something like that. And any delay in the project, and there are always delays, basically come at your cost. Yeah, because you're not just sitting at the end of the signaling delivery. The signaling itself very often sits at the end of the entire project delivery. So any delay in building the railway corridor falls back on the signaling system, and any delay in the signaling system falls back on testing and commissioning. Any delays in digging the tunnel falls back on building the rail corridor, which falls back on signaling, which falls back on testing and commissioning. So you in your position and in your discipline of work are always at the receiving end. You're always sitting at the very, very back end, and any time delay will basically eat into your time. Because if you say, you are the one person who are not allowed to say I need more time, because that means the end date is pushing out. Yeah. So I can imagine part of the magic you need to do in your job, and I'm using the word magic very deliberately here, is how to squeeze the amount of testing that has to be done in order to avoid unsafe situations into the available amount of time that you've got. And the thing that I have in mind, I'm not sure whether you followed that at the time. There was an accident during CBTC tests in Hong Kong a few years back.
Yes.
I think that was in 2019, if I'm not mistaken.
Correct. The shadow running.
Yeah, where two trains collided with each other at slow speeds. And in hindsight, what they basically found out during the investigations, that there were three test facilities, one with the client on site, one with the supplier on site, and the third one with the supplier back in headquarters. And all three test facilities were able to replicate this train collision easily. So the conclusion was basically, if somebody had tested this correctly, that train collision would have been found during offline tests, and the train would never have to collide in the field. And to me, that basically indicates the importance of risk-based testing. Yeah. So if you have a test that would normally take 3 days, but hey, you only have 3 hours because whatever, I don't know, the software was delivered late or what have you. How can you focus on the task that really could lead to the biggest impact, the biggest hazard? And train colliding, I mean, there are only so many train paths where there's actually a possibility that trains can run into each other. more often than not, trains just run in parallel and there's no real issue. But what would be, sorry for the long lead up here, what would be your response to that? How do you think you can address this if you really have to squeeze your test time significantly?
So I think that the part for us is if we have to take a step back from that. The element that we need to understand is the test quantification. So what are the requirements to test? Yeah. So we have a requirement. What feeds off that is obviously the test that we need to do. So that includes the interface systems, the durations. Yeah. Once we have that, what I would call, let's say, the test database. Let's say we have 1,000 activities that we need to perform. We know that these are safety critical interfaces, priority calls. Then we try to look at what can be tested off-site. Again, I go back to the point that I made earlier. So what can be validated, off-site, be that in a lab, be that in a test track. So we try to de-risk that part of it. But then we need to look at what predominantly happens on these projects when time is squeezed is that we say, right, we have 1,000 activities to perform, We know that the software drops will give us these various functionalities at different points in time across the project. And then we have the actual build. So it could be that the railway corridor is being built going ahead, proceeding as it should be. However, the tunnel ventilation control system, the functionality of that, so that the remote control of that, is not available. So we don't have the software interface. So we can facilitate tunnel vent by local control, which is fine, but that then proves that our testing is back-ended. So once you overlay the software availability and functionality to the systems required to the actual infrastructure availability, you can prioritize your testing on location-based activities, So that's one level, but I think it's the scrutiny of the planning. The scrutiny of the planning for me is if you're working to a T-6 process, what I mean by that is a T-6 weeks. You're scheduling your tests day by day, You maximize the time you have in the tunnels, We know, as per the test database, that these 30 scenarios are critical one items that need to be performed. So that's my part of it. Let's say T-52 weeks out, strategic level planning. We need to know of the 1,000 scenarios that we need to do, what are safety critical? What are our priority? And that makes your planning and coordination a lot easier rather than running at that last minute. So I think it's the elements of control that you put around planning, what you put around implementation, and then what you put around literally analysis. What I mean by that, test, pass or fail. If we have a fail, what does that look like? Is that a safety critical event, or is that failure relevant to someone not knowing how to perform the test, or is it a functionality issue as well? So I think the building blocks that you put around TNC facilitate that or allow you to prioritize the test that you need to do, but also manage people's expectations. You've clearly identified that these, say, 30 scenarios are critical for the delivery. The amount of time you're able to do that, you've done these, and the back end of that is that subsequently you have these 970 tests that need to be performed elsewhere as well. So
I'm conscious of the time. You need to go, and it's the first time, I must say, the first time in all my podcast interviews that it's physically hurting me to interrupt and to basically wrap this up, even though you haven't even finished to answer your first question, which was about your career development. So if that's okay with you, and I'm very certain it will be very okay with me and also with the listeners, is if we could have a follow-up at some point in the future, probably a few weeks out. But I think, well, just to give you a fair chance to answer the first question, where you actually worked on projects like Crossrail, and then you came to Australia. I kept working on other tunnel projects, the Metro Tunnel in Melbourne, the Crossrail in Brisbane, which obviously for the Australian listeners would be very, very, very interesting, like the comparison between Crossrail and the Australian tunnel projects and all this kind of stuff. So I need to apologize, but the conversation was so interesting. But we need to wrap up. So all that's left for today is basically thanking you for your time and hoping that it's possible that you may make some time again for another hour in, 2 or 3 weeks or something like that. That would be really great. So thanks for today. It was super interesting, and I hope to present you to the listeners again. And I hope that everybody out there listening is as interested in this conversation as I was. It was captivating, really.
Dr. Frank, definitely. And thank you so much for your time. And again, I do have a tendency to speak very fast. So I'm hoping in the next session, an hour will be enough for us as well, yeah, personally. So I believe it will be. I'm joking on that part of it, yeah. But yeah, thanks so much for your time. It's been really, really appreciated. And I look forward to speaking to you again very soon.
Thanks very much. Not talking too much, so really wrapping this up. To all the listeners, if you liked that episode, then please check out some of the other ones, which may not be quite as captivating as this one, but are still very, very good. And I don't want to put down the other guests of the podcast. They are really, depending on your interest, very, very good episodes out there. And for now, as usual, keep it simple and bye for now.
Hi, it's Doc Frank again, real quick before you head off. If you are a fan of communications-based train control or short CBTC, there's an event coming up in September that you absolutely don't want to miss. It's the first virtual global CBTC conference. It's called CBTC World Summit 2023, and it's happening on the 20th and the 21st of September. There will be 3 sessions of about 6 hours duration each for 3 different global regions, one for Asia Pacific, one's for North and South America, and one's for Europe and the Middle East. So wherever you are in the world, one of those sessions will be during the daytime in your time zone, and you can watch it live for the full 6 hours with 6 presentations. The kicker about this is that all other presentations, including the ones from your own session, will be available for replay via recordings. So that means that if the other session should be in the middle of your night, you can still watch it on demand at a time that's more convenient for you and doesn't interfere with your good night's sleep. The conference is available for registration right now at my training portal under docfranktraining.podia.com/summit23. I repeat that, docfranktraining.podia.com/summit23. I'm putting a lot of effort into this conference. It will be an absolute blockbuster event, and I very much hope to see you there. Until then, keep it simple and bye for now. Hey, Doc Frank here, host of the Rebel Conversations podcast. Thank you for listening.